Bismillahirrahmanirrahim. Assalamu alaikum, dear students. As you know, we are studying new syllabus mathematics. It's book 3, and we are doing chapter number 2. Today, in lesson number 12, we will solve some further questions of exercise 2b, which are related to inverse functions. This is question number 7. In this question, two functions are given. F of x is equal to 7 minus 3 over 5x, and the second function is g, which is g of x is equal to 1 over 4 x minus 6, and you are asked to find the values of these. Now here in first part it is f inverse 3, that is the value of the inverse function of function f when x is equal to 3. We are not asked to find the inverse function. So without finding the inverse of this function, we can find the value of f inverse at 3, x is equal to 3, by using the definition of the function and inverse function. You can solve this problem by finding the inverse of these two functions first, and then put x is equal to 3 in the inverse function. But without finding the inverse, when you are not asked to find the inverse, we will use the definition. This is the definition of the function y is equal to f of x, and x is equal to f inverse y. Now here you are asked to find the value of the inverse function of f when x is equal to 3. We suppose that this value is equal to a. There will be an inverse function of f when we will put x is equal to 3 in that function. There will be some value of that function. So we suppose that that value is a. Now this is f inverse y is equal to x. In this case y is 3 and x is a. Writing this or undoing this, we can write it like this: y is equal to f of x. So here 3 is equal to f of a. Putting the value of x, which is a, in the function f and equating it to 3, solve this equation to get the value of a, which is 6 and 2 by 3. Because we have supposed that a is equal to f inverse 3, so replace a by f inverse 3, and its value is equal to 6 and 2 by 3. Its third part is g inverse 5 is equal to a. So again we will use this definition, and we can write 5, which is y, equals to f of g of a. 5 is equal to g of a. Now in the g function, replace x by a. 5 is equal to 1 over 4 a minus 6. Solve this equation for a, and we get a is equal to 44, because we have supposed that a is equal to g inverse 5. So replace this a by g inverse 5 and put it equal to 44, which is the value of g inverse 5, and this value is 44. In sixth part, we are asked to find the difference between the value of the inverse function of f when x is equal to 4 and inverse function of g when x is equal to 4. So first find the value of the inverse function of f at x is equal to 4 in this similar way. Suppose f inverse 4 is equal to a. Use the definition of the inverse function. 4 is equal to f of a. Replace x by a in the function f and solve this for a. We get a is equal to 5, because we have supposed that a is equal to f inverse 4. Replace a by f inverse 4 and put it equal to 5. Similarly, find the value of g inverse 4. We suppose that g inverse 4 is another value which is b. Using the definition of function and inverse function, 4 is equal to g of b. Replacing x by b in g function, we get an equation 4 is equal to 1 over 4 b minus 6. Solving this equation, we get 10 is equal to 1 over 4 b, and b is equal to 40. Because b is replaced with g inverse 4, we get g inverse 4 is equal to 40. Now we are asked to find the difference between these two values. We have found the value of f inverse 4, which is 5. We have found the value of g inverse 4, which is 40. So writing this expression and putting the values and solving this, we get minus 35. So value of f inverse 4 minus g inverse 4 is equal to minus 35. Question number 8. In this question, a function f is given which is expressed by the expression ax square plus bx, and two conditions are given, that is the value of this function when x is equal to minus 2 is 20, and value of this function f when x is equal to 4 is equal to 32. Using these two values, these two conditions, we will have two equations. First equation, using first condition, that is the value of the function f when x is equal to minus 2 is equal to 20, we get an equation 2a minus b is equal to 10. Similarly, using second condition, which is the value of the function f when x is equal to 4 is equal to 32, we get another equation which is 4a plus b is equal to 8. Now these are the two equations. We will solve equation number 1 and equation number 2 simultaneously, because in equation number 1 the coefficient of b is minus 1, and in equation number 2 coefficient of b is plus 1. So we will add these two equations. To eliminate b, 2a minus b plus 4a plus b, the left hand sides of equation number 1 and 2 equals to 10 plus 8, the right hand sides of equation number 1 and 2. Plus b is cancelled with minus b, and we are left with 6a is equal to 18 and a is equal to 3. Put this value of a in equation number 1 or equation number 2. We get 2 into 3 minus b is equal to 10, or minus b is equal to 4, and b is equal to minus 4. So we are able to find the values of a and b by using the given conditions in the question. In question number 9, a function is h, and this function is expressed by this expression px square plus qx. Again, there are two conditions given. One is the value of the function h when x is equal to 1 equal to 2, and value of the inverse function of h when x is equal to 36 is 3. You are asked to find the values of p and q. The function is given, write this function. Use condition number 1, which is the value of the function when x is equal to 1 is 2. Replace x by 1 on the right hand side of this function. We get an equation which is p plus q is equal to 2. Similarly, using the second condition, which is h inverse 36 equals to 3. Again, we haven't got the inverse function of h, but it is given that the value of the inverse function h at x is equal to 36 is 3. So we will use the definition of function and inverse function, this one, and we will write 36 is y and 3 is x. So bringing this h inverse from left hand side to right hand side, we will get 36 is equal to h of 3. That is the value of the function at x is equal to 3. Put x is equal to 3 in the right hand side of the function, we get another equation. Simplifying, we get the simplified form of the equation, which is 3p plus q is equal to 12. Equation number 1 is p plus q is equal to 2, and equation number 2 is 3p plus q is equal to 12. We will solve these two equations simultaneously because the coefficient of q in equation number 1 is plus 1, and the coefficient of q in equation number 2 is also plus 1. When same coefficient have same sign, we subtract two equations to eliminate the variable. To eliminate q, we will subtract 1 from 2. The left hand side of equation number 2 minus left hand side of equation number 1, this is equal to right hand side of equation number 2 minus right hand side of equation number 1. Removing these brackets, minus q will be cancelled with the plus q, and we will be left with 2p is equal to 10 and p is equal to 5. Put this value of p in equation number 1 or equation number 2. We put this value in equation number 1, and we get the value of q, which is minus 3. In this, we were asked to find the values of p and q. We are able to find the value of p, which is 5, and value of q, which is minus 5, by using the two conditions in the question. Hence, evaluate these two. So to find the value of this function when x is equal to minus 1 and x is equal to 2, we will replace p and q in the original function by the values 5 and minus 3. So our new function will be h of x is equal to 5x square minus 3x. Now find the value of this function when x is equal to minus 1. Replace all x's by minus 1. Simplify, we get h of minus 1 is equal to 8. Similarly, the value of this function h when x is equal to 2 is equal to 14. In question number 10, you are given that the function f of x is equal to 5x over 2 minus 4x. Now this is a rational expression. The function f of x is expressed by a rational fraction. You are asked to find the inverse function of this function f of x. So this is straight away we will write this function, and we will use the 4 steps to find the inverse of a function. The first step is that we replace f of x by y. So we get y is equal to 5x over 2 minus 4x. Now because right hand side of this is a fraction, we can write left hand side also as a fraction y over 1 and cross multiply. We get y into 2 minus 4x is equal to 5x. Remove the brackets because there are two terms involving x. To express x in terms of to make x the subject, we will collect all the terms with x on one side. So transfer minus 4xy to right hand side, we get 2y is equal to 5x plus 4xy. Now take x common from the two terms on the right hand side. 2y is equal to x into 5 plus 4y, or x is equal to 2y over 5 plus 4x. To find the inverse, we know that we first replace fx by y, then we make x the subject of the equation, and then we replace x by f inverse x and all y's on the right hand side by x. So this is the inverse function for the function f of x. And state the values of x for which f inverse x is not defined. So any function which is a rational function cannot be defined when the denominator of that function or fraction is 0. So this function, inverse function of the function f, is not defined when 5 plus 4x will become 0. So solving this equation, you can find the value of x, which is equal to minus 5 by 4. And then you are asked to find the values of f inverse at x is equal to 4 and inverse at x is equal to minus 6. We have already found an expression for the inverse function, which is 2x over 5 plus 4x. Replace all x's by 4 to get the value of this inverse function when x is equal to 4 and this is equal to 8 over 21. And the value of the function inverse function at x is equal to minus 6. Replace all x's by minus 6, simplify and get the value, which is 12 over 19. This question number 12 is same as question number 9. In this question, a function is given which is ax plus b, and two conditions are given. F of 1 is equal to 1 and f inverse of 5 is equal to 2. Using the first condition, we get equation number 1, which is a plus b is equal to 1, and using the second condition and using the definition of function and inverse function, we get 5 is equal to f of 2, and putting x is equal to 2 in the function, we get 2a plus b equal to 5. Now in equation number 1, the coefficient of b is 1, and in equation number 2, coefficient of b is also plus 1. Both b has same coefficient with same sign. So we will subtract these two equations. From equation number 2, we will subtract equation number 1. So the left hand side of equation number 2 minus left hand side of equation number 1 is equal to right hand side of equation number 2 minus right hand side of equation number 1. Removing the bracket, we get 2a plus b minus b equals to 4. Minus b is cancelled with plus b and we get a is equal to 4. Put this value of a in equation number 1 and solve to get the value of b, which is equal to minus 3. Hence find f inverse x. So because function is a function in which there are two constant terms a and b, the values of a and b have been found. The value of a is 4 and value of b is minus 3. We will first put these two values in the function and we will get a new function, which is 4x minus 3. Now we can find the inverse by using the 4 steps. We will replace f of x by y and we get an equation y is equal to 4x minus 3. Now we will make x the subject. Y plus 3 is equal to 4x and x is equal to y plus 3 over 4. Now replace x by f inverse x and all y's on right hand side by x. So the inverse of the function f of x is equal to x plus 3 over 4. And you are asked to find the value of this inverse function when x is equal to 7 and x is equal to minus 5 and 1 over 2. So replace x is equal to 7, simplify and get the value of f inverse 7, which is equal to 2 and 1 over 2. Similarly, replace x is equal to by minus 5 and 1 over 2. Simplify and get the final answer, which is 5 over 8, minus 5 over 8. Question number 15 is also same as question number 9. In this, there is a function g which is mx plus c. The condition is given g inverse minus 3 equal to 0. Using the definition of the function, minus 3 is equal to g of 0. Minus 3 is equal to, put x is equal to 0 in the given function. We get m of 0 is equal to plus c equals to minus 3, and solving this we get the value of c, which is equal to minus 3. The second condition is g inverse 1 is equal to 2. Using the definition of the function and inverse function, we can write 1 is equal to g of 2. Replace x by 2 in the function g. We get another equation which is 2m plus c equal to 1. The value of c has already been found. C is equal to minus 3. Put this value of c in this equation. C is equal to minus 3. We get 2m minus 3 is equal to 1. 2m is equal to 4 and m is equal to 2. Find the value of g of 5 and g inverse 4. So we will put these values of m and c in this function to get a new function 2x minus 3. The value of this function when x is equal to 5